And here we are for another episode of Astronomy Daily. I'm Steve, your host. It's the 3rd of June, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, it's nice to be back with you again. I've been busy again this week. Also up and down with some kind of tummy bug. Sucks to be human sometimes, doesn't it? Anyway, well, here's someone who never has to worry about tummy bugs. Hi, Hallie. How are you going?
Things are always shiny, Steve.
Oh, well, that's good to hear. There are some interesting things happening in the sky this week.
There sure are my favorite human. I've got a story about a Japanese billionaire who wanted to go into space.
What is it with these billionaires? Can't they find something more humanitarian to do with their money down here on Earth?
There are plenty of options for that in today's world, for sure. But this fellow just canceled his plans.
His plans to go into space. Wow.
So we'll find out why.
Okay, what else?
A team from Rhode Island have developed a way to map the moon in a new way.
Well, we know making maps is hard enough here on Earth, but on another world it must be really difficult. So what's this new way they've found?
It's a way of showing terrain using 2D images in a process called shape from shading. It sounds fascinating.
Now that does sound fascinating. I can't wait to hear that one.
And you better be quick because tonight the planets align.
A bit like Lotto. It's 6 in a row, isn't it?
It won't happen again for a while. Can you guess how long the next occurrence will be?
Well, knowing the kinds of numbers we talk about on this podcast, it's going to be a long while, I would say.
Longer than long, Steve.
Really?
Really?
That long?
Really?
Wow, that's a long time. And also, I'll be digging into the latest news from Boeing Starliner and the latest lander on the moon. So,
Let's go. Japanese billionaire Yusaku Maizawa on Saturday canceled his planned flight around the moon on a SpaceX vehicle because of uncertainty about when it may be possible. The tycoon in 2018 launched plans for the lunar flyby voyage. He bought seats for 8 traveling companions in 2022 for what would be his second space journey after his 12-day trip to the International Space Station on a Russian Soyuz spacecraft in 2021. Maizawa was aiming for the moon trip for 2023. A target seen by most space observers as overly optimistic given the progress of SpaceX's Spaceship megarocket project. It would have been the first private flight around the moon. That project became unfeasible, said the mission organizer on Saturday in a statement posted on its website. Without clear schedule certainty in the near term, it is with a heavy heart that Maizawa made the unavoidable decision to cancel the project. Maizawa had selected 8 people for his Dear Moon project from 1 million applicants. They included a lead rapper for the K-pop group Big Bang, and Americans DJ Steve Aoki and filmmaker Brendan Hall. Separately on Saturday, Maizawa said in his message on X, "I can't plan my future in this situation and I feel terrible making the crew members wait longer, hence, I made the difficult decision to cancel at this point in time. I apologize to those who were excited for this project to happen," he said. He said he signed the contract with SpaceX in 2018 assuming the launch would be possible by the end of 2023. It's a developmental project so it is what it is, but it is still uncertain as to when Starship can launch. SpaceX's 2 test flights of its megarocket last year ended in explosions minutes after liftoff. In a third test in March, its spacecraft was lost as it descended back to Earth. Maizawa and his producer in December 2021 became the first self-paying tourists to visit the space station since 2009. Maizawa made his fortune in retail fashion, launching Japan's major online fashion mall, Zozatown. There was a time when maps of the moon were created from telescopic observations and drawings. Indeed, Sir Patrick Moore created maps of the moon that were used during the historic Apollo landings. Now researchers have enhanced a technique to create accurate maps from existing satellite images. Their approach uses a technique called shape from shading and involves analyzing shadows to estimate the features and shape of the terrain. Future lunar missions will be able to use the maps to identify hazards on the surface, making them far safer. Researchers at the Brown University in Rhode Island have helped refine a process used to map the surface of the moon, making it more accurate than ever before. In their paper, published in the Planetary Science Journal and authored by Benjamin Boatwright and team, details the enhancements to the mapping technique. It can generate detailed models of the moon's surface to highlight craters, ridges and slopes from composites of 2D images. Highly detailed maps are of crucial importance to lunar missions and help the planners to identify the safest place to land. They can also use them to identify areas of particular interest that require further study, enabling the whole mission to be far more efficient. Missions such as the Artemis project will benefit when it heads for the south pole of the moon, an area which is not well mapped. High-resolution maps of the area will aid the autonomous landing systems to avoid hazards. Creating the maps is a time-consuming job and is difficult to be accurate when lighting levels on target area are poor. The interpretation of shadows has been less than effective until now, with the team addressing the issues. In their paper, the team explain how advanced computer algorithms can automate a lot of the process and improve the resolution of the generated models. Their new software gives lunar astronomers the necessary tools and information to create larger, more detailed maps of the surface. To allow lunar scientists to create a map from images requires at least 2 images of the same area. Each image must be perfectly aligned with its counterpart so that features in one are in exactly the same place in the other. Until now, the technology has not been able to take multiple images of an area and create a perfect map. Boatwright said, "We implemented an image alignment algorithm where it picks out features in one image and tries to find those same features in the other and then line them up, so that you're not having to sit there manually tracing interest points across multiple images, which takes a lot of hours and brain power." Along with the image alignment algorithm, the researchers created quality control algorithms and filters to remove poor quality images from the alignment process. By only inputting good quality images to the process means the output will be of far higher quality. It is a similar model that astronomical imaging employs when processing multiple images through stacking and alignment techniques. To evaluate the accuracy of their work, the team compared the output from existing maps of the moon to look for errors. To their delight, they found that maps created using their enhanced shape from shading technique was more precise compared to those acquired during traditional techniques. On June 3rd, an alignment of 6 planets, Mercury, Mars, Jupiter, Saturn, Uranus, and Neptune, will be visible shortly before sunrise from dark, high vantage points with minimal light pollution. This rare event requires optical aids to view all planets. Stargazers will have an incredible opportunity to look for 6 planets in Earth's solar system on June 3rd. Mercury, Mars, Jupiter, Saturn, Uranus, and Neptune will appear, from some dark, weather-free vantage points on Earth, to form a more or less straight line in the night sky, but it'll take some optical assistance to see them all. The alignment is a bit of an illusion, astronomers are quick to point out, given the widely varying elliptical path of each planet's orbit around the Sun. But the uncommon arrangement could prove captivating indeed, if local weather does not interfere. The planetary alignment is likely to be most visible 30 to 60 minutes before sunrise, looking east from a dark, high vantage point with minimal light pollution and an unobstructed view of the complete horizon. If you were somewhere out in space other than on Earth, these planets would not appear aligned at all, said Dr. Alphonse Sterling, astrophysicist at NASA's Marshall Space Flight Center in Huntsville, Alabama. It is not unusual to see 2 or 3 lined up, but to have 6 of them line up like this is uncommon. Mars and Saturn will be identifiable with the naked eye, and Mercury and Jupiter may also be spotted close to the horizon. To add Neptune and Uranus to the lineup, however, will require the use of a telescope or high-powered binoculars. You can see it basically anywhere there isn't a ton of light pollution, Sterling said. You just need a clear view looking east. Jupiter and Mercury will be the last to join, rising just above the horizon. You won't see 6 bright dots lined up. In the best circumstances, you can see Jupiter, Mercury, and Mars and Saturn. You'll need binoculars or a telescope for the others. Alignments of 6 planets happen infrequently, depending on the orbit and position of each planet as seen from Earth. Indeed, we may see an encore performance later this year. The same rough alignment of 6 planets could be visible in the pre-dawn hours of August 28 and again on January 18, 2025. That's certainly more common than a full planetary alignment, in which all 8 planets in our solar system would appear to fall into approximate formation on the same side of the Sun. Given all the factors involved, including the orbital plane, speed, and distance of each planet, estimates suggest it would take more than 300 billion years to happen just once. Back to you, my favorite human.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, and as always, thank you so much, Hallie, for those stories. And thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our parent podcast Facebook page, which is Space Nuts Podcast Group. And we hope to see you there.
Astronomy Daily, the podcast.
Last-minute computer trouble cancelled the Saturday's launch attempt for Boeing's first astronaut flight, the latest in a string of delays over the years. Two NASA astronauts were strapped into the company's Starliner capsule when the countdown automatically was halted at 3 minutes and 50 seconds by the computer system that controls the final minutes before liftoff of Boeing's Starliner. With only a split second to take off, there was no time to work out the latest problem, and the launch was called off. Technicians raced to the pad to help the astronauts Butch Wilmore and Sonny Williams out of the capsule atop the fully fueled Atlas V rocket at Cape Canaveral Space Force Station. Within an hour of the launch abort, the hatch was reopened. The team can't get to the computers to troubleshoot the problem until the rocket is drained of all its fuel, said Troy Bruno, CEO for the rocket maker United Launch Alliance. Bruno said one of the three redundant computers located near the rocket at the pad was sluggish. All three must work properly to proceed with a launch, he said. Depending on what needs to be fixed, the next launch attempt could be as early as Wednesday. If it doesn't blast off this coming week, then that would be it until mid-June in order to move the rocket off the pad and replace the batteries. This is the business that we're in, Boeing's Mark Nappy said. Everything's got to work perfectly. It was the second launch attempt. The first try on May 6 was delayed for leak checks and rocket repairs. NASA wants a backup to SpaceX, which has been flying astronauts since 2020. Boeing should have launched its first crew around the same time as SpaceX, but its first test flight with no one aboard in 2019 was plagued by severe software issues and never made it to the space station. A redo in 2020 fared better, but parachute problems and other issues caused more delays. A small helium leak in the capsule's propulsion system last month came on top of a rocket valve issue. More valve trouble cropped up 2 hours before Saturday's planned liftoff, but the team used a backup circuit to get around ground equipment valves working to top off the fuel for the rocket's upper stage. Launch controllers were relieved to keep pushing ahead, but the computer system known as the ground launch sequencer ended the effort. Of course, this is emotionally disappointing, NASA astronaut Mike Fink, the backup pilot, said from neighbouring Kennedy Space Center shortly after the countdown was altered. But he said delays are part of spaceflight. We are going to have a great launch in our future.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A Chinese spacecraft landed on the far side of the moon Sunday to collect soil and rock samples that could provide insights into the differences between less explored regions and the better known near side. The landing module touched down at 6:23 a.m. Beijing time in a huge crater known as the South Pole Aitken Basin, the China National Space Administration said. The mission is the sixth in Chang'e's moon exploration program, which is named after a Chinese moon goddess. It is the second designed to bring back samples following the Chang'e 5, which did so from the near side in 2020. The Moon program is part of a growing rivalry with the US, still the leader in space exploration, and others, including Japan and India. China has put its own space station in orbit and regularly sends crews there. The emerging global power aims to put a person on the moon before 2030, which would make it the second nation after the States to do so. America is planning to land astronauts on the moon again for the first time in more than 50 years, though NASA pushed the target date back to 2026 earlier this year. US efforts to use private sector rockets to launch spacecraft have been repeatedly delayed, trouble with Boeing's Starliner, and earlier Saturday a Japanese billionaire called off his plan to orbit the moon because of uncertainty over the development of a mega rocket by SpaceX. NASA is planning to use the rocket to send astronauts to the moon. In China's current mission, the lander is to use a mechanical arm and drill to gather up to 2 kilograms of surface and underground material over about 2 days. An ascender atop the lander will then take the samples in a metal vacuum container back to another module that is orbiting the moon. The container will be transferred to a re-entry capsule that is due to return to the Earth in the deserts of China's Inner Mongolia region about June 25. Missions to the far side are more difficult because it doesn't face the Earth. This requires a relay satellite to maintain communications. The terrain on the far side is also more rugged, with fewer flat areas to land. The South Pole Aitken Basin, an impact crater created more than 4 billion years ago, is 13 kilometres deep and has a diameter of 2,500 kilometres, according to a report by China's Xinhua news agency. It is the oldest and largest of such craters on the moon, and so may provide the earliest information about it. The agency added that the huge impact may have ejected materials from deep below the moon's surface. And just like that, another episode comes to a grinding halt, and I want to thank you for sticking with us on Astronomy Daily, and we'd love to see you next week. Don't forget that Hallie's cousins Charlie and Anna will be gracing you with the airwaves with all the news from science, space science and astronomy through the week, so don't forget to join them as well. We'll see you next week. Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.